Welcome back to the Deep Dives, where we take these massive, complex topics and really just try to cut through to what matters.
Yeah.
And today we are strapping in for I think, a really high-altitude look at a topic that seems simple on the surface.
It does.
The drone industry. But here's the thing. Our sources are screaming at us right out of the gate. The very name, the drone industry, is a trap.
It's a total conceptual trap. It's the central idea we have to unpack today.
A myth that's actively sabotaging decisions.
Exactly. The moment you treat all drones, every single one, as one coherent category, you've already lost. You misallocate capital, you misdirect regulations, and you get your engineers focused on the wrong problems.
So what are we really talking about then?
We're talking about a cluster of, I don't know, dozens of highly specialized, totally separate markets. Each one has its own economics, its own rules, and a completely different recipe for success.
Okay, let's unpack this with that aha moment analogy immediately, because I think once you get this, it just changes how you see everything.
It really does.
Thinking about the drone industry broadly is a strategic failure. So talking about the car industry.
Yeah, exactly.
But never distinguishing between, say, a Formula One racing team.
Which is really a high-tech R&D lab that happens to be a sport.
Right. And then you've got this massive, optimized fleet of Amazon delivery vans.
Totally different. All about unit economics, logistics, scale.
And then, I don't know, a mission-critical ambulance service.
Exactly. They all use wheels and a motor, but that's where the similarity ends.
Right.
Their supply chains, their tech stacks, their profit models, their regulatory hurdles, they're from different planets.
And the drone market is fractured along those exact same lines.
Identical. A drone built for surveying a construction site is operating under completely different constraints than one designed to deliver blood in rural Africa. They're just not the same business.
That sets our mission perfectly. So for this deep dive, our goal is to just shatter that monolithic view with cold, hard data. We're going to dive into the segmented reality of the market, really analyze why Western companies are struggling so much against giants like DJI. And then, and this is the part I find fascinating, we're going to spend a lot of time on how the Global South is becoming this incredible innovation lab.
A constraints-driven lab. It's key.
And then we'll wrap it all up with a clear, actionable playbook for anyone looking to build or invest in this space.
That's good.
Fantastic. So let's start with the scale. If the industry isn't one thing, it's definitely a massive collection of things. So what's the size? What's the trajectory? Give us that context.
Okay, so the snapshot we have right now is pretty clear, and it shows this accelerating adoption curve. For 2023, the global commercial drone market was estimated at $29.86 billion.
Wow. So just shy of 30 billion.
Yeah, substantial figure. And it shows that a lot of those early, experimental applications are now becoming reliable, repeatable business workflows.
Okay, so that's where we are. Where are we going?
Yeah.
Because the growth is what's attracting all the capital.
The projections are what should grab everyone's attention. It's expected to nearly double by the end of the decade. We're looking at a projected value of $54.76 billion by 2030.
54 billion.
Which is a compound annual growth rate, a CAGR, of about 9.1%. That's strong, sustained growth. It tells you drones are moving from this niche, early adopter tech to a mainstream, indispensable industrial tool.
And this is where it gets really interesting for me. What's actually pushing that growth? It's not just, slightly better batteries. This is a fundamental shift.
It's a perfect storm of three major forces, and they all feed each other. First, and this is the most important one, is proven return on investment, ROI.
We're past the what-if phase.
We are way past it. Companies are now consistently showing massive, clear cost savings, especially in things like large-scale asset inspection, surveying, mapping.
Give me an example.
Okay, think about inspecting a 50-mile oil pipeline. A human crew might take 2 weeks, and there are huge safety risks. A drone can do that basic inspection in 2 days with zero risk and way more consistent data.
So the business case is just a spreadsheet now. It's not a dream.
It's a verifiable financial fact. And that economic incentive leads directly to the second driver.
Which has to be the regulations finally catching up.
Precisely. The second driver is regulatory evolution. This is the key that unlocks all the big money. We're seeing the gradual, sometimes frustratingly slow approval of BVLOS.
Beyond visual line of sight.
Right. The shift from a pilot having to physically see the drone to allowing it to fly autonomously for miles, that's what unlocks widespread delivery, long-distance monitoring, huge agricultural operations. Without BVLOS, the most valuable applications are, literally grounded.
And the third driver, I'm guessing is the tech itself getting smarter, not just better at flying.
Absolutely. The third driver is technological advancements, and this is way broader than just the aircraft. We're seeing huge leaps in the supporting systems.
Like what?
Better sensors, like high-res LiDAR, multispectral cameras that can see things the human eye can't, better battery density, and, critically, AI-powered data processing. The drone isn't just gathering data anymore, it's starting to interpret it on the fly.
That brings us right back to segmentation. So if this massive market isn't one thing, what are these distinct verticals that are basically their own little economies?
Our sources are really clear on this. Strategic success means you have to master one of these, not dabble in all of them.
Okay, so let's run through them.
Let's start with precision agriculture. This market is all about optimization. We're talking spraying, crop monitoring, checking plant health with advanced metrics, predicting yield. The hardware here is often a big fixed-wing drone, totally different from what you'd use elsewhere.
Right, because it needs to cover thousands of acres. Totally different from, say, construction and infrastructure.
Completely. In construction, the operators are focused on physical structures, stability, volumetric measurements.
Their constraints are different.
Totally. They're doing site surveying, progress monitoring, comparing the real-world build to the digital blueprint, and then critical asset inspection bridges, wind turbines, power lines.
Which needs a different kind of drone.
A heavy-lift, multi-rotor drone with incredibly precise GPS and high-res thermal cameras to find tiny cracks. The software has to generate these hyper-accurate 3D models.
Then you have the pure data play, mapping and surveying, which is its own certified world.
Yes, they specialize in high-precision topographic maps, 3D models, GIS data. This needs centimeter-level accuracy. It's a whole different standard. And then you jump to the totally different economics of logistics and transportation.
This is the delivery market.
All about last-mile delivery, point-to-point transport of things like medical supplies, or even just internal warehouse inventory management.
And that logistics market is dominated by players who are using aircraft that a construction surveyor wouldn't even recognize.
Absolutely. They have companies like Zipline and Wing, who we'll get into more, using fixed-wing aircraft or advanced VTOLs. Their business isn't selling hardware, it's network management and flight choreography.
And we can't forget public safety and security.
Never. Search and rescue, firefighting support, accident scene reconstruction. That segment operates under government mandates. They need extreme reliability and thermal cameras above everything else.
Each one of those has its own budget, its own customer, its own definition of what failure means. That really drives home the myth-busting idea.
It's fundamental.
Okay, so now let's talk about the elephant in the room. The single biggest reality check in the commercial drone world, DJI.
Dajing Innovations.
Yeah.
You can't talk about any of this without addressing the shadow they cast over the entire market.
What are the numbers? How dominant are we talking?
DJI is the undisputed leader. Most estimates put their command of the global commercial drone market at somewhere between 70 and 80%.
70 to 80. That's not just a market leader. That's almost a monopoly in terms of hardware volume.
It's an extraordinary level of market penetration for any single manufacturer, and it shapes every single decision every competitor makes.
And this isn't just good marketing. What are the structural advantages they have that let them keep this lead?
First and foremost, it's their unmatched R&D and manufacturing scale. They are based in China, and they leverage the hyper-efficient Shenzhen manufacturing ecosystem.
And Shenzhen isn't just a city, it's an entire system.
It's a dense concentration of suppliers, rapid prototyping shops, specialized labor. It allows them to iterate faster and, crucially, at a much, much lower cost.
So frame that for me. If a Western company needs 6 months and, say, $5 million to prototype a new part,
DJI can probably do it in 3 or 4 weeks for a fraction of the cost, because every single supplier they need is within a few square miles. This leads directly to the China price.
meaning their hardware is just vastly cheaper to produce.
Vastly. And they control the whole ecosystem, the cameras, the stabilization, the software. It's all seamlessly integrated.
But as you said, their biggest strength is also their biggest vulnerability in some places.
Exactly. The weakness is geopolitical concerns and data security. In a lot of Western markets, especially for government, defense, critical infrastructure, DJI hardware is seen as a potential risk.
So there's an opening.
There's an opening for smaller players to compete on trust and security, not on price, because they will never win on price.
Okay, so if DJI is tier 1, selling the most hardware globally, who's in that critical tier 2? The specialized Western alternatives trying to find a foothold.
The tier 2 companies don't even try to fight the price war. They specialize in these secure, high-value niches. Government, defense, industries where data integrity is everything.
And they often rely on government programs like the U.S. Blue UAS list to even get in the door.
That's their market access right there.
So who are the key players? Let's start in the U.S.
Skydio is the clear leader in this tier. Their specialization isn't just flying. It's AI-powered autonomous navigation and obstacle avoidance. They've positioned themselves as the premier American drone maker, targeting the U.S. government and critical infrastructure clients who will pay a massive premium for security and autonomy.
Their edge is the software, not the hardware volume.
It's all about the software stack.
And in Europe,
You've got Parrot from France. Similar strategy. They provide a secure, non-Chinese alternative, focusing heavily on data security, encryption, and sovereign solutions for European clients. They're competing on trust and compliance, knowing they can't touch DJI on cost.
okay, and let's quickly touch that specialized delivery segment, which is almost its own tier 4. These aren't just drone companies, they're network companies.
That is exactly the right way to put it. This segment is super specialized, capital intensive, and it needs totally different engineering.
Like Zipline.
Zipline is the perfect example. They're the global leader in autonomous medical delivery. They've built these huge networks in Rwanda, Ghana, Nigeria. Their system uses a fixed-wing drone, a catapult launcher, and a parachute delivery. The innovation isn't the plane, it's the logistics network that cuts delivery times from days to minutes.
And then there's Wing from Alphabet.
Right, focusing on retail delivery in suburbs using these very specialized VTOL aircraft, vertical takeoff and landing. They're really logistics companies that happen to use drones. Their entire business lives or dies on regulatory approval for airspace management.
It's so clear these are just fundamentally different businesses.
They're powered by complex unmanned traffic management software. The drone is just a tool in a much bigger machine.
This segmentation perfectly sets us up for our next big topic, the Western strategic pivot.
Yeah.
Because facing DJI's hardware dominance, Western companies had to realize that going head-to-head was a losing fight.
It was unwinnable, economically and structurally. They had to pivot their entire strategy.
So what are those core structural problems that forced this pivot?
They are immense. We talked about the China price, but let's quantify it. A Western company trying to build an equivalent mass-market drone faces production costs that are 2 to 5 times higher.
2 to 5 times.
Yeah. And it's not just labor costs, it's the efficiency you lose from not having that concentrated Shenzhen ecosystem. So right away, you can only compete in markets where someone is willing to pay a huge premium for security or sovereignty.
And that high cost is then compounded by issues with capital and regulation.
Absolutely. There's a huge capital mismatch. Venture capital in the West, it loves high-margin, fast-growing software companies. They look at the long, expensive, risky R&D cycles for hardware, and they get nervous.
So there's chronic underinvestment in the hardware needed to actually compete.
Exactly. And then you have the regulatory drag. The FAA, ESA, they're making progress, but the slow pace of approving things like widespread BVLOS flights caps the revenue. If you can only fly where you can see the drone, your business can't scale. The big money is locked behind slow regulatory approvals.
So, prohibitive cost, a market split by geopolitics, and slow regulation. The old strategy of just building a better drone was dead on arrival.
Completely.
So what are the big lessons learned that have reshaped the Western playbook?
The biggest lesson, learned the hard way with a lot of failed startups, was a painful one. Hardware is hard.
Yes.
There was this belief for a while that software was enough. That was wrong. You can have the smartest AI in the world, but if the drone it's on is unreliable or costs too much or you can't get parts for it, your software is useless. The solution has to be a reliable, cost-effective system.
So the strategy had to shift from chasing the lowest cost, which was impossible, to something else.
To resilience and control. The new focus is supply chain resilience. The pandemic and trade wars showed everyone how fragile the global supply chain was.
Right.
So Western companies are now actively dual sourcing components from places like Taiwan, South Korea, even if it costs more. They're designing for modularity, using commercial off-the-shelf parts, COTS components, so they're not dependent on one single supplier for one tiny chip.
And this resilience thinking feeds into what you call the full-stack imperative. What does that mean in practice, selling a full-stack system?
It means you're selling a complete end-to-end solution to a business problem. You're not selling parts. The drone itself becomes almost incidental. The full stack means the hardware, the flight autonomy software, the data platform, the customer support. It's all one integrated, optimized package for one specific job.
So you're not getting commoditized.
Exactly. If you just sell the hardware, you're in a price war with DJI. If you just sell the software, you're at the mercy of whatever garbage hardware the client is using. You have to sell an integrated capability that guarantees a result.
Can you give us a concrete example?
Skydio is perfect. They don't just sell a drone, they sell their core autonomy engine combined with software like Skydio 3D Scan. This lets a utility company fly a complex bridge inspection, generate a perfect 3D model, and plug that model directly into their engineering software. They're selling automated data capture, not a flying camera.
They control the whole pipeline to make sure the data is actually useful.
And that's where the value is.
Which brings us to what might be the most critical piece of the Western strategy: AI. Why is AI the strategic moat here?
Because it hits all the weak spots at once, it helps offset the high cost, the skilled labor shortage, and it provides a value that goes way beyond what the hardware can do. It works on two levels.
Okay, let's start with the first level: AI for operational autonomy.
This is basically the pilot replacement, or at least pilot augmentation. AI enables hands-free flight in really complex environments, and this is the key. It dramatically reduces the need for highly skilled, very expensive human pilots.
So your operational cost per flight goes way down.
Way down. If one technician can supervise a swarm of 10 autonomous drones instead of needing 10 certified pilots, you've just fundamentally changed your business model. That helps offset the China price disadvantage on the hardware.
So AI makes the drone cheaper and easier to operate at scale. What's the second, more valuable level of AI?
This is AI for intelligence. This is the big one. The drone captures images, which are just data. The AI's job is to instantly analyze that fire hose of data to find actionable insights.
Like what?
It's detecting a hairline crack in a wind turbine blade automatically. It's measuring a gravel stockpile down to the cubic meter. It's flagging crop disease 6 weeks before a human could ever see it.
So companies can charge for the answer, not for the flight.
Exactly. You're selling the predictive maintenance alert, the decision support, not the data collection service.
That completely reframes the sales pitch.
It has to. Founders have to stop pitching a drone company. They need to pitch a vertical intelligence company that happens to use drones.
So we are a solar asset intelligence company.
And we use automated drone data capture to guarantee your farm's peak output. The premium is on the proprietary AI model, which is hard to copy, not on the flying hardware, which is a commodity.
So mastering that one specific workflow is the only sustainable advantage.
It is. The winners will build platforms that take the image data, turn it into a clear, actionable output, and plug that output right into the client's existing workflow. That's where the real business is.
Okay, let's pivot our focus now, dramatically. We've talked about the high-tech, security-driven West. Let's go to the global South, where the constraints are, physical and elemental. This region is a huge source of innovation.
It's the ultimate laboratory for resilience. The global South countries in Africa, parts of Asia, Latin America, it presents this huge opportunity to leapfrog traditional infrastructure.
What do you mean by leapfrog?
Why spend billions and decades building roads to every remote village when you can use a high-speed drone to deliver medicine?
And the solutions that come out of these places,
Yeah.
they're built differently.
The intense constraints, unreliable power, harsh environments, no supply chains, they force the development of rugged, resilient, appropriate technology. If a drone can survive continuous, high-volume operations in the heat and dust of rural Ghana, it can work anywhere.
So those solutions will eventually be exported back to the West.
Absolutely. For disaster zones, remote industrial sites, anywhere that needs extreme reliability.
Let's get specific on those hurdles, because they're so different from what Western companies face. What are the big infrastructural and technical problems?
You can break them into a few categories. First, infrastructure. Unreliable electricity is number one. You can't run a fleet of battery electric drones if the grid is down half the day.
So charging becomes a logistical nightmare.
A total nightmare. Second is limited connectivity. There's no stable 4G or 5G in many of these remote areas, so you can't rely on real-time data upload. The drone has to be able to operate offline.
And the physical environment itself is just brutal on the hardware.
It's brutal. Intense heat kills lithium batteries. Dust and humidity get into all the moving parts and cause failures. And on top of that, there's a total lack of local physical infrastructure. There are no specialized drone repair shops.
So what's the real-world impact of that?
The reality is that a single broken propeller, a $50 part, can ground a $50,000 drone for weeks while you wait for a replacement to clear customs. It just destroys the economics.
And beyond the physical, there are these unique regulatory and social barriers.
Yeah, and they require a totally different strategy. Many countries have underdeveloped or just non-existent drone regulations, or the laws they have treat every drone like a military weapon.
Which is then compounded by bureaucracy.
Opaque import licensing, complex certification. It can stall a vital project for months.
And what about the sociocultural side of it?
You often run into deep community mistrust. People see a drone and they think surveillance, not medicine delivery. So you have to do a lot of long-term community engagement to build that trust. And that's paired with a big skills gap, which means you can't just scale by hiring locals. You have to build training programs from scratch.
Okay, so this incredibly difficult environment forces real fundamental innovation. And our sources point to one technology as being absolutely critical for the global south: the hybrid fuel battery powertrain.
This is the essential innovation. Because pure battery electric drones, with their short flight times and slow charging, there's a non-starter in these conditions. The hybrid system is the only way to get the operational window you need.
Walk me through how it works. It's not just a generator strapped to a battery.
No, it's a sophisticated range extender. You have a small, very efficient generator on board, running on something common like gasoline or diesel. The battery is still there to handle the high-power moments like takeoff or hard maneuvers.
But once it's cruising,
Once it's in stable cruise flight, the little generator kicks in and acts as an onboard charger, constantly topping up the battery. It's designed to run at its most fuel-efficient RPM, providing sustained energy.
and the impact of that is just massive.
It's profound. First, you get extended range. Flight times can be doubled or tripled, which is a game changer for covering vast territories. And second, you have liquid fuel flexibility. It's much faster and easier to find a liter of gasoline in a remote village than a stable power outlet. It completely untethers you from the grid.
But to make this whole thing work, you can't just drop in the tech. You have to build a local ecosystem.
Absolutely. It stands on 3 pillars: people, process, and technology.
Let's start with people.
This has to be locally owned. You have to train and fund local drone entrepreneurs to run these services. You need dedicated community liaisons to build trust. And you need regulatory champions inside the local government who can create safe sandboxes for innovation to happen.
And the process pillar is about the messy reality of the last mile.
Yes. The flight is the easy part. The process is hard. It's the last mile logistics. How does the box of medicine get from the parachute drop zone to the patient at 3 a.m.? That needs local people, secure storage, communication systems. It also means clear rules on data sovereignty, making sure local data stays local. And it requires public-private partnerships to share the risk and get government buy-in.
And on the technology side, beyond the hybrid power, what else is appropriate tech?
You need ruggedized and modular drones that are easy to fix with basic tools. But just as important is offline-capable software: mission planning, flight control, basic data analysis. It all has to work without an internet connection. The data gets uploaded when the drone gets back to base, not in real time.
The use cases here are so compelling because the ROI is immediate and often life-saving. Medical delivery is the obvious one.
It's the gold standard. Zipline proves it. Delivering blood and vaccines in minutes instead of days saves lives. The value is tangible. The same goes for precision agriculture, helping smallholder farmers increase their yields. The economic benefit is immediate.
And the sources also highlight something I found fascinating: land tenure mapping.
It's fundamental for economic development. In many places, traditional surveying is too slow and expensive. Drones can create accurate land maps quickly and cheaply.
And why is that so important?
Because that map allows a farmer to get a formal title to their land, and that land title becomes collateral they can use to get a bank loan. The drone service literally transforms their land from a passive asset into active economic capital. It's a profound leap.
Okay, we've moved from the myth of one industry through DJI's dominance, the Western pivot, and into the innovation of the global South. Let's look forward now to the future, which is about more than just single drones.
It's the logical next evolution. We're shifting from single drone solutions to orchestrating heterogeneous robot teams, coordinated multi-agent systems.
And the value is no longer in the drone itself.
The value is in the AI orchestrator, the hive mind, that directs the whole fleet.
Give us an example. Disaster response seems perfect for this.
It's a perfect high-stakes example. Imagine a major building collapse. The mission deploys initial scout drones with thermal cameras to get a quick map and find hotspots.
Okay.
At the same time, you deploy heavy-duty ground robots for lifting debris, and maybe even small, highly resilient snake-like robots to get into voids and search for survivors.
And the AI is coordinating all of them.
The central AI orchestrator is managing the whole scene. It assigns tasks based on each robot's capability, manages their battery life, makes sure they don't collide, all without a human having a joystick every single one. It gives the human first responders a complete, synthesized picture to act on.
That's a huge leap, and it depends on other technologies converging.
Yeah.
Let's start with advanced autonomy.
This means drones moving way beyond pre-programmed flight paths. We're talking about true, real-time situational awareness. The drone can tell the difference between a bird and a crack in a pipeline, and it can reroute its own mission without human input. It becomes an intelligent agent.
And what about this intersection with additive manufacturing, aerial 3D printing?
This is radical. Imagine a large drone equipped with a 3D printer nozzle. It could fly out to an offshore oil rig and print a polymer patch directly onto a microcrack.
Wow.
Or in a disaster zone, it could print temporary shelter walls, maybe even using local materials like sand or mud. It could drastically cut down the logistics and time for critical repairs.
And we're also seeing totally new materials being developed.
Yeah, the material science is catching up. You have biodegradable drones for single-use missions in sensitive areas like seed dispersal. They're made from things like mycelium that just break down. And on the other end, you have self-healing materials, polymers, that can automatically repair small cracks, which dramatically increases the drone's lifespan in those harsh environments we talked about.
So if the drones are getting smarter and working in teams, the human jobs have to evolve. The pilot role fades away. What are the new high-value jobs?
The focus shifts entirely to fleet management and data. The most critical new role is the UTM operator unmanned traffic management. These are the air traffic controllers for the drone highway.
A very technical, high-stress job.
Absolutely. Then you have the drone swarm coordinator who manages the behavior of a whole fleet working on one task. You'll have the aerial 3D printing technician, this hybrid expert in robotics and materials science.
And finally, the people extracting the real value.
The drone data analyst and the AI trainer. These are the people who interpret the data and, more importantly, train the AI models to spot the defects. They're the ones who ensure the answer you're selling is actually correct. The value has completely moved from the flight stick to the software and the insight.
This has been an incredibly detailed journey. Let's bring all these threads together now and synthesize that core thesis one more time.
The synthesis is crystal clear. The strategic goal is not to build a better drone. It's to master the specific workflow and constraints of one single, highly specialized vertical.
And if you're not doing that,
If you're not solving a $100 million problem in a $100 billion industry, you're probably going to fail. The future is about robotic ecosystems that matter, not just more drones in the sky. The general drone industry is dead. Long live the specialized robotic markets.
okay, so let's make this actionable. For the founders and investors listening right now, what's the playbook? What do they need to do?
For founders, the rules are very specific now. 1, choose one vertical solar farm maintenance, bridge inspection, whatever, and obsess over the entire workflow. 2, lead with software and AI. Treat the hardware as a commodity tool. 3, design for security and regulatory compliance from day one. And finally, change your business model. Sell a service, dates, or a SaaS intelligence platform, not a piece of hardware.
And for the investors, how should they be placing their bets?
Investors need to stop funding any general hardware company that's trying to compete on price with DJI. It's a losing game. Instead, spread your bets. Put money into one or two of those highly specialized vertical SaaS plays. Invest in strong DICE networks that have proven unit economics, like Zipline. And finally, make some bets on the infrastructure enablers, the UTM systems, the data platforms, the hybrid power solutions. Bet on the picks and shovels, not the generic flying machine.
Finally, let's talk to the entrepreneurs in the global south. They're building the next generation of resilient tech. What should they avoid and what should they focus on?
First, what to avoid. Do not wait for perfect regulations to show up. Work with your local regulators to create sandboxes now. And do not blindly copy expensive Western models that were built for a world with reliable electricity.
So if they avoid those traps, what's their unique advantage? What should they be exporting?
They need to turn their local constraints into exportable expertise. They need to double down on developing those robust, offline-capable software systems and those super reliable hybrid powertrains. Those are solutions born of necessity that will work anywhere in the world.
So start with one high-impact use case and build from there.
Exactly. Medical delivery, agricultural support, something with an immediate, measurable ROI, and partner with government development actors early to get that support. Build the local workforce. That's the sustainable path.
So the Global South is essentially teaching the rest of us how to build truly resilient, truly robust systems from the ground up.
It is. The lessons they are learning in resource scarcity and mandatory reliability are invaluable for any market that might face infrastructure challenges.
This has been a really profound exploration. We've moved from this general assumption about the drone industry to these hyper-specific strategic imperatives. It seems the future value is completely divorced from the hardware itself.
Absolutely. The value is not in the quality of the image the drone takes, or even how long it can fly.
So as we wrap up this deep dive, we want to leave you with a final provocative thought. If the value is no longer in collecting the data, but in the automated action that's triggered by the AI's analysis of that data, what specific answer are you actually paying for?
Are you buying a drone? Or are you buying the guaranteed detection of a critical failure 6 months before it happens?
The answer to that question is where all the real money is going to be made.
Think about that. The action is the value.